I have already discussed about some very basic brief on traction system. Okay, so today we'll discuss about the basic power electronics control of traction motor. Means which type of traction motor is there, so that is important. Basically, we are considering the DC series motor. Okay, so different as per the requirement of the motor. Okay, so controlling principle is different. Okay, so controlling methods are different. Okay, so if we are using DC series motor, so we have to design the power electronics converter related to the control of the DC series motor. Okay, means traction motor. If it is AC series motor, so in that case same control idea, means same power electronics converter may not be used. Okay, it's not be used, not may not be, it's not be used. So in that case we have to design inverter based control. Okay, then three phase induction motor. Again it is a three phase motor, so we have to think about it, the vector control of the motor. So in that case frequency and amplitude magnitude both should be varied. Okay, so that only possible. Okay, that only possible if we are changing the different control methodology. Okay, if we are changing to different power electronics control methodologies, so by this way it is only possible to implementation. Okay, so especially you know that on the traction motors having some electrical features. Okay, so for designing any of the motor we need to know about what is the features, means what we cannot use the DC shunt motor. Basically shunt motor application is a constant speed application. Okay, so it is not possible to use shunt motor. Okay, so which type of motor you have to you need to select. Okay, which type of motor you are going to select. So that depends that selection depends on your depends on your motor specifications. What kinds of specifications are important? So first required specification is your high starting torque. Okay, so you know that you have to overcome the friction effect. Okay, means static friction effect initial phases. So you have to depend upon the high starting. So you have to select the motor which having high starting torque. Then simple speed control. Okay, so the speed controlling method should be very simple. If you see in DC series motor that it having very high starting torque. Okay, and the simple speed control method means you can go for that armature voltage control up to base speed. Okay, and above the base speed means rated speed, you can go for that field weakening method or field control method. Okay, so flux you can vary, but there is a option. Okay, how much you can control the flux. Okay, it should be there up to critical values of flux line. Okay, if the value of flux is below the critical value of flux, so motor will be stopped. Basically it is not able to overcome it is not possible to overcome that moment of inertia of the motor if you don't have the significant amount of flux. So initially from the very beginning of the motor starting, you cannot use that field control method. Okay, so motor is running, then you can only go for that field weakening method. Okay, so that's why some method you need to follow. Means if the momentum has come, then you can only go for that field control method. If momentum is not there, if it is not constant speed, motor is not in your constant speed or the rated speed, you cannot implement that method. Okay, so better communications. Okay, so better communications, regenerative braking. So implementations of the regenerative braking. So if you see that DC series motor as well as the induction motor, the regenerative braking methods in induction motor, different methods are there for the regenerative braking, but in DC series motor, so only single methods is there. Suddenly you can you say like that your voltage, okay, your input voltage is suddenly you can omit from the system. So what happened? Okay, so that is your regenerative braking. Then better communications means it's not like only the connecting of the motor to the system, it will work.
Sir, you said we use a DC series motor, but not the shunt motor. But in case Of DC series motor, we cannot use regenerative braking. It's not possible.
No, 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 no. It's possible. Special arrangement, it can possible. Okay. What happened in regenerative braking? You first tell me. Tell me first. What happened in regenerative braking?
Sir, in regenerative braking, the voltage across the armature is greater than the terminal voltage, as a result of
So,
which current
so
flows from your armature to the terminal side.
hmm.
That is regenerative braking. But in case of series, this is not possible.
Why it is not possible? What will be the problem? The current direction through the field. What will be the problem?
Sir, field should remain constant. Mm,
Field should remain constant, but you can bypassing the field terminal also. You can bypassing the field terminal also. Regenerative braking means what happens? Suddenly motor is working as a generator mode. Means how it will possible? You just see in lab. Did you see anything anytime the regenerative braking in laboratory? Am I talking to Shokti? Na? What is your
yes,
name?
sir.
Shokti.
Yes, sir.
Okay, na. So did you see in lab that regenerative braking?
Yes, sir.
Yes, na. So how is
In
it?
machine lab.
Huh?
Yes,
Which
sir. In
lab?
machine lab. But it was
Machine
but
lab.
for
How
shunt
is it
motor.
performed? How is it performed?
It was for shunt motor, sir.
It was hand motor, no problem. But how is it performed?
Sir, we kept the field current, field voltage and currents equal as to that, and after, when we ran the motor, we suddenly stopped it. That
No, that's why I'm asking you that you can perform in the lab, but practically what happened, I'm telling you, in case of regenerative braking, we need to use two motor. Okay, one is called that driving motor, another is called the testing motor. Okay, so what is the purpose of the driving motor? Driving motor purpose is so first you need to check the polarity of the both of the motor. Okay, first try to realize the problem. Okay, two motor set is there. Their shaft is coupling. Okay, their shaft is common shaft that you are using, and both of the shaft is coupled by the that screw that is called what we said that is pivoting, not pivoting, the bearing through the bearing. Okay, first you have to run the test motor. Okay, so if you need to see the direction of the test motor. Okay, so in which direction it is rotating, from right, from anti-clockwise or clockwise, then you have to stop that motor, and you need to check it in the test driving motor. Okay, so what will be the directions? Okay, so if you see both of the motor is rotating the same direction, so first they are connected, means their common shaft is there, so their arrangement is face to face arrangement. So if one motor, means driving motor, is rotating in anti-clockwise, so other motor should rotate in the clockwise. Okay, so then it only possible. Are you getting my point?
yes, sir.
Hello. So if one is anti-clockwise, another is clockwise, then that pairing is possible. Okay, if the driving motor is rotating in the same direction, both are in anti-clockwise, then you need to change the terminal of the driving motor. Okay, then what happens? Then then both are will be the same direction. Then you have to start both of the motor. Okay, then you need to control the armature. Okay, you need to control the armature of test motor. Okay, so up to it will be go to the base speed. Then what happen, you can see that armature current is rising. There is a special type of ammeter. Okay, there is a special type of ammeter. It is zero detecting ammeter, means that is armature current, that is measure the armature current. So initially in motoring mode, means current will be positive. Okay, initially the current pointed out the zero terminal. Okay, then it is gradually increase that current, means it will be 0 to it will be increase up to certain value. Okay, then what you need to do, then your another motor also rotating in the same speed, means base speed. So if you find out, if you see the tachometer value, you can see both of the tachometer value is coming summation of the both of the rpm. Okay, then what you need to do, that driving motor is there, that motor you can go for that field control. Okay, same rated motor, so same speed is there, so now you are going for the field control. Then what happened, the prime mover speed of the test motor is more than of your normal speed. Then what happened, then if it is more than, so you can see it acts like a generator. Okay, so that current terminal, you can see that zero crossing ammeter, so it is coming back to the zero, then ammeter current shows the negative one. Okay, by this way you can see the regeneration. Okay, regenerative braking. So in case of DC series method, the main obligation in your field. Okay, in your field. So in that case, you have to arrange field such a manner, so there will be what is the basic problem, that field current should not be, the direction of the field current should not be changed. Okay, in DC motor, that's why when you are going for the regenerative braking, so you need to do the special arrangement. So you have to reach, means change. Okay, you need to change the field terminal. Okay, first, and you can also increase the prime mover speed. Okay, if you go beyond the prime mover speed, then what happen, so definitely it will regeneration, so terminal voltage, so generation voltage definitely different, mainly high of your terminal voltage na? If you able to increase the prime mover speed, it's possible. Okay, so that's why I'm giving that example. Shunt motor, there is no problem. Shunt motor easily you can go it for easily, but in case of DC series motor, you have to arrange the special arrangement. Means you need to special arrangement. Otherwise, you cannot go for that regenerative braking. Are you able to understand, Shakti?
Yes, sir. Sir, you mean to say that these arrangements are made in that costing period?
Yes, 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 yes.
Okay, okay, sir.
Okay. Otherwise, how they can understand? So
Mm.
after free running, it will be there. Okay. ठीक है, so that's the so capacity of the withstanding the voltage fluctuations that I'm telling you. The protection, low voltage protections, normally you have to think about in motor. Okay, so there should not be low voltage. Okay, if the voltage is low, means current will be high, I square or T loss will be high, so that may burn out your motor. So low voltage protection should be there. Okay, then the next point is your mechanical features. What are the most important mechanical features? Light in weight. Okay, motor weight should be light. Small space requirement. Okay, so motor should be in the compact in nature. Okay, so another important issue is the robust and should be able to withstand the vibration. Okay, so robustness of the motor should be there. So we need to check the motor dynamics. Okay, so how robust your motor is it? Okay, so if it is robust in nature, so there will be no problem. Okay, so that's why you need to check. That's why you need to check different method. Okay, so before selection of the motor, you need to check so these features, some electrical features and mechanical features. Then traction motor control, what are the commonly used controlling method? Okay, so first one is your rheostat control for the dynamic braking, and not like only dynamic braking, also that rheostat is connected in the field, parallel operations of the field. So sorry, that rheostat also connected parallel with your field. So sometimes the field getting method also done in rheostat control. Then series parallel control, that combinations means when motor will be running in the series, when it will be in parallel, depends upon your current rating of the motor. If the load is high, so you need to change the configuration from series configuration to parallel configuration. Okay, so otherwise what happens, so sometimes load is high means motor will draw the more current. Okay, so that's why series parallel combinations for the speed control, it is also important. Okay, then field control method. Field control method, you can go for the field weakening method. So field control morning, then buck and boost method. Buck boost method means another power electronics control. So buck mode means suddenly means you are reducing the motor terminal voltage. Okay, so that is your buck mode. Boost mode means you are increasing the motor terminal voltage. That means is your armature voltage control. Normally motor having three controls, you know that one, that is armature voltage control, armature resistance control and field resistance control or field control. Normally armature voltage control and armature resistance control both are more or less same. Okay, so that's why it is back mode control and boost mode control. Means you can changing the armature voltage terminal with by using the power electronics converter. That's why that term is there, back and boost method. Okay, then metadyne control, metadyne another machine configuration. So okay, so in the metadyne means you are also controlling the field. Okay, special arrangement is there for the special type of machine. So now the metadyne is not in our syllabus and not in our common machine lab. Okay, so those institute have, you can get it. I think metadyne also been available. Maybe our old machine lab of our institute, very old machine lab. Basically, metadyne is now obsoleted. Na? So special type of machine, metadyne is coming. Special type of machine. Then Sage motor, all are there. That are the examples of the special machines. Okay, that I am telling about Arno converter. These all are the examples of the special machines. Now, instead of this type of machine, we are using the power electronics converter, especially inverter control. Okay, the harmonic mitigations. Normally, we are changing the different configurations, winding configurations like traction order winding. Okay, so distributed winding we are using for removing the number of harmonics, eliminating of the harmonics. Okay, so same configuration, same type of idea we are also using in inverter. Okay, to eliminating the harmonics. Okay, so now power electronics converters are in our studies. So that's why that old machine, okay, old machineries are obsoleted. Okay, basically machines means it will take a lot of additional energy, means additional energy drawing, means it will be drawing by the machines additional energy. So that's why we can omit them instead of solid state devices. Okay, so you can make the system more energy efficient. Okay, then thyristor control. Why thyristor control? Why not MOSFET control, BJT control? Okay, or IGBT control. IGBT control also will possible, but thyristor means thyristor having a huge voltage. It can carry huge current as well as huge voltage. So that's why thyristor control. That's why we are giving the more focused on the thyristor control. Okay, so it's a latching device. So phase control and chopper control. So thyristor control means you are using thyristor as a device, solid state device for that voltage control method, and as well as sometimes phase control means AC voltage control level, means firing angle you are doing the control. Thyristor are the latching devices. Okay, but in case of MOSFET, what happened? That amount of voltage it will not be noticed by the MOSFET. It is not the beyond the capacity, that voltage range. So MOSFET is only using for that high frequency application. Like the frequency application is more than 500 kilohertz. Okay, sorry, frequency application is up to 500 kilohertz. Okay, so that application we can use the MOSFET. But IGBT means and BJT again, it's a current control device, not a voltage control device. MOSFET is a voltage control device. So you can cascade or you can combine both BJT and MOSFET. So you will get the IGBT circuit. Okay, IGBT devices. So it having good switching frequency as well as some good voltage carrying capability, moderate way, but it's not like that IGBT. So instead, it's not like that thyristor. Okay, so instead of thyristor, we can use IGCT circuit. Okay, IGCT devices that are very costly. So in cycloconverter drives, so in big traction or battery driven machines, okay, battery driven transportations, okay, so we are normally using that IGCT circuit. Okay, so the current scenario, if you see that we are also using GAN devices, means GAN devices, silicon carbide devices, which having lot of switching frequency as well as good voltage means peak inversion, PIV, peak inverse voltage capability is very good, twice of your input voltage. So that kinds of solid state devices right now we are using for the traction purpose. Okay, that is not given in the slides and that is not discussed in very well manner in the slide. Basically, we should focus about the very basic studies about the utilization. Okay, basic studies. Okay, then then rest of the thing is and in the domain of research. Okay, so we should give some of the basic idea on the research, but we should be maintain the basic track of our course guideline. Okay, so I think you are able to understand that what is phase control and chopper control. Then braking is important. What type of braking you can see over here. So you know that electrical braking. So all the time repeatedly you are learning means had this type of terminologies like plugging or the reverse current braking, rheostatic braking, regenerative braking. Okay. So this is shunt motor, this is series motor as well as induction motor. In induction motor, regenerative braking also possible, but again induction motor there is some different types of regenerative braking. Okay. So you have to do I think you already took one course electric drive. So if you follow the book of Dubey, okay, Professor G.K. Dubey, okay, so you, in that case you can get different braking methodologies, means electrical braking methodologies, okay, for the different motor. So that is discussed over here: induction motor, DC series motor, shunt motor. But in shunt motor, it is series motor. It also written in the Dubey book that it is not possible, the regenerative braking. But here we are using it, the regenerative braking. Basically we need to use the shunt motor, series motor. So anyhow we have to arrange the regenerative braking for it. So that is our fundamental, that is the basic motivations for why the regenerative braking you are using for this series motor. Okay, then mechanical braking also be there, like compressed air braking, vacuum brake. Okay, so you know that is another braking is there, the brake shoes. Okay, brake shoes is there, that directly magnetic brake shoes. Okay, that is given, that magnetic track brakes. Okay, so on the when you try to stop that train, emergency braking, that emergency braking is there in the room of guard. Okay, locomotive guard. So he or she can put that put those brake for magnetic locking of the wheel. Okay, so automatically it will be stopped. And vacuum, you know, all of you, vacuum brake, air compressor brake. Okay, so you, when you are traveling through the train, so you can hear that sometimes the compressor is on and off. Okay, in locomotive means EMU, those are traveling in the motor course, sometimes they can hear that compressor is turned on, okay, for maintaining the air pressure. Then suddenly compressor will be off. So sensor will be there, means like your, the sound will be like that, your the bike maintenance shop, like that, the compressor is then air checking. Okay, so sound will be like that. Okay, so it will start, then it will be off for maintaining the air pressure. Okay, in vacuum what happen, suddenly if you pull the chain, so some of the air will be entered in the vacuum and brake will be locked. Okay, so that's why you should not pull out the chain. Okay, in case of emergency situation you can only pull it out, otherwise it is a criminal offense. Okay, recent trends in electric traction. Okay, recent trends in electric traction. So what are the most important trends, means tap changer control. So what is your tap changer control normally in case of motor? Okay, so internal electrifications. Okay, internal electrifications of the motor coach. Okay, so there are few important few important points are there. Okay, so in case of motor, okay, when you are taking the overhead connections through taking the electricity from the overhead connections, okay, through pantograph. Okay, so one transformer is there, the transformer is situated inside of your motor coach. Okay, so inside of your motor coach, so what is the purpose of the transformer? That transformer having three winding. Okay, so one primary, another three windings, means it is a four winding transformer. Okay, so one winding is used for the traction purpose. Okay, so one primary winding, another, sorry, one HV winding, and it having three LV winding. Okay, so LV winding, one LV winding is dedicated for your traction purpose. Okay, so you can use that winding is an used as a primary, that winding is an use of a primary of a auto transformer, or you can say like that, that winding is sometimes is auto transformer. Means what happen, they are sharing the primary winding and secondary winding, they are sharing itself. Am I right? Okay, so they are sharing itself, so there is a tap changer. Okay, there is a tap changer. So in case of auto transformer, if you vary that value, so what happened, so that traction motor voltage also being changed. So power electronics converter, anything if you want to use, so you have to use those voltage before feeding the traction motor. Okay, you need to feed the energy, means you need to feed the voltage traction motor through power conversion stage, means through power electronics converter. Okay, so if you change the gate pass of the power electronics converter, so output voltage of the converter is changed, and that may be the input of the traction motor. Okay, so that is one tap changer method. Okay, so you can change the tap, so definitely direct voltage. In case of if you don't have any power electronics converter, so what happen, you can directly put that one through a DC-DC converter, sorry, AC-DC converter, I mean rectifier, then you are put need to the traction motor. Okay, so if you change the tap value, if you change the tap of the auto transformer, means that is dedicated for your traction motor, so automatically the voltage will be changed. If the voltage will be changed, the motor input voltage is varying, and the speed of the motor will be changed. Another two winding is there, that is called auxiliary winding 1, auxiliary winding 2. One auxiliary winding is specially dedicated for the number of relays. Okay, there are LT relays, low tension relays, high tension relays. Okay, lot of relays are there, as well as some internal machineries operation like pento, like uplifting the pantograph. Okay, compression motor. Okay, so then in case of water logging, means in case of express, means mainline transportation, the water, so pumping systems are there. Okay, then other different small machineries are there. Okay, so that will be taken care about your that will be taken care about your one winding, auxiliary winding number 1. Another auxiliary winding is there, that is responsible for the internal electricities. Okay, so you know that railway track, means inside of the train. Okay, lot of fans are there, light all are there. Okay, that fans are in the single phase fan, but how much voltage rating is there, did you check it? Normally if you see the charging point, if you see the charging point in the inside of the chain, so you can see it will be 110 volt charging point. Okay, so you know that the voltage level is maintained, it is 110 volts. Again, it can, you know that Washington DC, so that conventions, when we are going for that NBA accreditation, so we need to maintain the specifications maintained by the Washington DC, means what Washington DC accreditation code na, so that is maintained. Okay, in the Indian Railways also, that is international standard 110 volt. Okay, the fans are designed, that is also for the special voltage level fan. So if any of the passenger can think, they just take it out from the fan, from the train, and they can use it in the home, so it is not possible. Okay, so special type of fan as well as special type of configurations are there. Okay, so all the thing will be maintained, all the thing will be specified at the special reading. Okay, so there are special code lines are there, so you have to design, those are working on the workshop, railway workshop, they are aware about that codes. Okay, so what kind of code they are using, code means it's like act. Okay, so IC act, you know that Indian electricity code, IEC code, like that way. So some standardization is there. Okay, code means some standardization for their application, so for their designing purpose, what will be the gauge of the wire, what type of insulation you need to be used, what will be the testing rating when you are testing your motor. Okay, vacuum testing is there, for insulations there is also the vacuum testing is there. Okay, so different testings lab also be inside of your workshop. Okay, so that also be maintained. Then that is tap changer control. Another thing is that the tap changer may be in two sided. Okay, so one is LV sided, another one is HT sided. Okay, so HT sided tap changer means where is it observed for mainline operations. Okay, for the mainline transportations, mainline locomotive, so you can see the tap changers are in HV sides. Okay, but in case of local train service, means city ride. Okay, means in your city ride means EMU. Okay, in case of EMU, that tap changers are connected in the secondary side. Okay, so secondary side, why it is be connected, so definitely there is some reasons are there. So all the time you are making the system on off you are doing. Okay, then what will be the problem if the tap changer in your secondary side? So what will be the big problem? Okay, in normal cases you have to think about it. So normal cases, what happen, the tap changer, if it is in secondary side, then secondary side conductor size means voltage is low, the sizing of the conductor is more. Okay, so current carrying capacity of the conductor is more. Okay, that's why if you make it in secondary side, so anyhow if you open the tap changer, if you change the tap changer, okay, on off the tap changer, then what happened, there is a huge problem of your, sorry, there is a leakage, not like direct leakage. So means current, you can understand that current leakage or flashing will be there. Okay, but in secondary side what happened, so normal EMU, so that flashing may be observed. Okay, that flashing may be capable to deal by that motor coach. Okay, there will be no problem. Basically it is short duration running, and that voltage and current rating is less, so flashing also been less. But in case of mainline transportation, if you make it in secondary side, that tap changer, so there will be the huge problem. So that flashing, the current will be more. Okay, so that's why basically it's a long line. So all the time if you try to change speed, so you need to change the tap changer, so more flashing will be there. So if you make it in high voltage side, so the flashing will be less. Because of what? Because the current is less, voltage may be more. So changing of the switch in high tension side, then main problem is that the insulation, there is additional stress in the insulation. But if you put the insulation good, okay, so there is no test, no such flashing. Okay, flashing may be mitigated or may be eliminated. That's why for mainline transportation, the auto transformer you are using, the tap changer is there. So in mainline transportation you are not, I think the auto transformer is not there, maybe. Okay, so in that case the normal transformer is there. After that one transformer you just add for the speed change of your armature of the traction motor. So in that case the tap changer is in your primary side, but in normal city ride the tap changer are placed in the secondary side. Okay, that's the reason. Then the chopper control. So if you see the back side of the train, so not back side, just base level. Okay, you can see lot of box type things is mounted over there. So that is called the battery. Okay, not like only battery mentioned, it has mentioned there battery or the charging circuit or the smoothing reactor. So you are getting the AC voltage na, so you need to rectify that value. Okay, if you are going to rectify that value, so you will get the ripple DC. Okay, that's why you need to pass that ripple DC voltage through the smoothing reactor. If that voltage is passing through the reactor, then what happen, that you will get the fixed voltage over there. Okay, that fixed voltage is used for the charging of the battery. Okay, that's why different boxes will be there. So chopper circuit also be there for controlling the speed. Okay, so means it is in buck mode or is it boost mode. Okay, means is that voltage is making if you, as per the changing of the gate pulse, so you can vary the armature voltage. Okay, so changing of the gate pulse, so mode of operation has changed. Okay, buck mode to boost mode. So normally we are using normally we are using buck boost converter. Okay, then microprocessor control, the control logics are required. So how to provide the control logic? So initially it was analog control, right now that all the thing is in microcontroller or microprocessor based control. Okay, so all the control strategies, then which one will be work, the gate pulses. Okay, entire process will be designed through the microprocessor or the microcontroller. Okay, normally we are using right now microcontroller. Okay, here you can see the basic configurations for the high frequency vector control. Okay, three phase induction motor. So three phase induction motor is there. So it is your IGBT or diode. Okay, I am telling about the bidirectional converter, means bidirectional operation also been possible. Okay, so IGBT diode configurations are there. So IGBT module. Okay, so rectifier is there. Then you are making that ripple DC. So the capacitor is there. Then that voltage, it's an inverter circuit. No? So input is your DC. Then as per the configuration of the switches, so that MOSFET, sorry, that MOSFET or that IGBT plus diode module will work, and you will get the voltage of the motor. Okay, here your encoder resolver means you are fetching the motor speed. Okay, that microcontroller is there, it is your actual speed. So current feedback also be there. Okay, then you should give some of the base speed. Okay, then you are processing that speed value, you are processing the error value. Okay, then gate driver is used for what? Total 1, 2, 3, 4, 5, 6 switches are there. So 6 gate driver is required, means sorry, 6 gate pulses are required to drive the IGBT module. Okay, so 6 pulses are there, so it is called the gate driver. Okay, all are the gate driver and you fed over it. Okay, so that's the process for the microprocessor or microcontroller. Okay, control of the DC, control of the traction motor. It is a induction motor. Okay, is an induction motor. Then DC and AC motor drives for the traction. So different power electronics control methodologies are there. So how do control them? So what are the power electronics control strategies? So first we are discussing about the in DC motor drives. So in case of DC motor drives, you know that DC current motors have the variable characteristics. Okay, white and are used for the extensively in the variable speed drives. So you know that DC motor you can change. Okay, you can change it. You can change it the speed of the motor from the below base speed to above base speed. Okay, by the changing the controlling methodology, like changing the input voltage, okay, of the motor, and as well as the changing the field current. Okay, so that is possible. Okay, so that's why the configuration is mandatory. Okay, the DC motor can provide the high starting torque. That is another important issue. That means it can easily overcome the static friction restriction. Also possible to obtain the speed control over the wide range. Okay, so that means zero speed to up to maximum speed. The sophisticacy of the speed. Okay, motor speed. Okay, so that depends which controller you are using and what is the zone of operation, means for which duration you are controlling. Okay, if one cycle is there, one cycle means half cycle is there. Okay, so half cycle means it is 180 degree. So for the selection of the firing pulse, you can keep any of the pulse up to 0 to 180 degree. Okay, but if the range, if you are distributed into 18 room. Okay, so how much distribution is there? For one room is for the 10 degree. 18 room means 180 degree. If you make it in 20 room, so one room is equals to 9 degree. Okay, so 9 into 20 means it is 180 degree. So okay, so 9 rooms mean, sorry, 20 room means individually 9 room. Okay, so 9 degree. So then definitely sophistication is more. That means smooth speed increasing, a smooth controlling of the motor, that you need to select the gate pulse, you need to select the control of the motor in such a manner that having very sophisticated control topology. Okay, and which having the wide range. That wide range is in your hand. Okay, how much wide range you are arranging for your lab purpose, you should not do for it for the wide range. So costing of the devices will be high. So in case of railways means traction, the costing factors, no. So the trains are working for the next 15 years, maybe 10 years. Okay, so if it is cost efficient, okay, if the smooth running is cost efficient, so you can go for it. But in case of laboratory, you don't need to use such amount of money for it. So in that case, you can make it normal. Okay, so such that way. Okay, the method of speed control normally simple and less expensive than those of the AC drives. Definitely, AC drives, again you have to path transformations are there, so you have to go for the method like generalized machine control method. I think that portion was covered in the machine 2 by Professor Rudra sir. Okay, by Professor Rudra. So that means generalized methods are there. Generalized method means ABC to DQ transformations. Okay, DQ0 transformation, then vector control, scalar control. Some of the portion may be covered in the drives class also by Professor by VRN sir. Okay, so that may be discuss some of your old classes. Okay, so that's why in DC AC drives it is quite difficult, but The other portion is easy. If you establish that method, there will be no problem. Okay, so DC motor play a significant role in modern industrial drives. Okay, so both series and separately excited DC motors are normally used in variable speed drives. Okay, but series motor are traditionally employed for the traction applications. So very old days, from last 50-60 years, that DC series motor you are using for the traction. So after invention of the railway, okay, means railway systems, and most of the cases DC series motor. But last 5 years, 10 years, the more trust given in the induction motor. Okay. Both series and separately excited DC motor are normally used in the variable speed drives. Okay, but series motor are traditionally employed for the traction application. Okay, due to commutators, DC motors are not suitable for very high speed applications and require more maintenance for do the AC motors. Okay, than do the AC motor. So AC motor, the maintenance cost is less. Also, it can operate in dusty area. But in case of DC motor, what will be the problem? Then commutator segment will be means covered with the dust. So that may be short circuited. Two segment may be short circuited. So the maintenance cost is very high in DC series motor compared to your induction motor. So that's why induction motor is much more suitable applications in the traction. If you able to, maybe the driver is different with the DC motor. The driving system is comparatively simpler in DC motor, but induction motor driving process is different. Okay, with the recent advantages of the power conversions, okay, advancement in the power conversions, means power electronics converters, control techniques, and the microcomputers, the AC motor drives are becoming increasingly competitive with the DC motor drives. So that I told you that also the future trend is towards the AC drives. DC drives are currently used in the many industries. It might be the few decades before the DC drives are completely replaced with the AC drives. That we told you that DC drives is replaced by the AC drives. Then another important features, the controlling rectifier. Okay, that controlling rectifiers. Okay, that controlling rectifier provide a variable DC output voltage from the fixed AC voltage, whereas the DC-DC converter can provide the variable DC voltage from the fixed DC voltage. Okay, that you can understand. So if you directly use uncontrolled rectifier, so you will get only one single voltage. But if you using different controller, okay, means control rectifier, so you will get the better controlling strategies due to their ability to simply to supply a continuous variable DC voltage control rectifier, and the DC-DC converter made a revolution in the modern industrial control equipments and the variable speed drives with the power level ranging from fractional horsepower to several megawatts. Okay, so that is the basic convention. So what are the method you can use for power electronics control for the DC drives? That is single phase drives, three phase drives, and DC-DC converter drives. Okay, single phase drives means if you are using single phase motor, so your input is your single phase AC, so definitely you can convert it to the DC. Single means rectify that AC to DC, then you can use that motor. Then you can control the speed, control the voltage. Okay, so you control the firing angle of that power converter, and definitely the output voltage will be varied. Okay, if the output voltage is varied, then you can go for that controlling of that DC motor. For in case of three phase drives, three phase input is there, so you can convert the three phase input to DC input. So ripple frequency more in case of three phase conversion, three phase AC to three phase AC to DC conversion over the single phase AC to DC conversion. So ripple frequency is more in three phase AC to DC conversion. So the filter size will be less in case of three phase AC to DC conversion. Okay, but the problem is that not problem, that output voltage also very high. Okay, the filter voltage whistling value should be high. Okay, then DC-DC converter drives means you can use the chopper drive. Chopper drive means choppers are used for the buck mode or boost mode. That means controlling of the DC motor input voltage. So that's the fundamental thing. So that's the introduction for the DC motor drive by using the power electronics converter. So my next class means tomorrow I will discuss about the operations. Okay, so all the converters means which converters are more suitable for the full bridge converter or half bridge converter or the semi control then semi converter. Okay, so which one is that more suitable for the which applications, if the semi converter is usable for the braking purpose or not. Okay, so that will be discussed in my next class. Okay, that in my tomorrow classes. Okay, so thank you. So today I can stop my session here. Okay, so if you have any queries, you can ask me. So or you can write it in the chat box. So I can explain some of the portion again if you have any kinds of doubt. Okay. Okay, so I think do not have all of you do not have more doubt on it. So we can conclude today's session through here. Okay, so if you have any doubt, you can note it down to your homework copy. Means homework copy. So then we can in my next class I can also clear those doubt if you have it. Okay, thank you. So we can stop today's session here.